a solid metal cube of length 2 centimeters is moving in the positive y direction. So I have shown the three axes over here, and this happens to be the x-axis, this happens to be the y-axis, let's say, and this is the z-axis. Alright, so here this solid metal cube is moving in the positive direction of the y-axis like so. Okay, and the speed of this cube is constant and it is equal to 6 meters per second. So let's highlight this important data. 6 meters per second is the speed, and the length of the edge of the cube is 2 centimeters. So this 2 centimeters is essentially 2 into 10 raised to minus 2 meters. Okay, there is a uniform magnetic field 0.1 Tesla in the positive z direction. So here in the positive z direction, a uniform magnetic field is present. Uniform means at different points in space, the magnetic field has the same magnitude. That is the meaning of uniform. And constant means at different points in time, the field strength is the same or constant. Okay, so constant pertains to time and uniform pertains to space. The potential difference between the two faces of the cube perpendicular to the x-axis, okay, has been asked. So essentially this face of the cube and this face of the cube. So herein we basically have to write down the formula for motional EMF. Simply speaking, we need to write down the formula for motional EMF. Motional EMF is nothing but V cross B dot dl. Okay, so here it is understood that V cross B has to be taken first and then it has to be dotted with dl. The other way does not make sense, because other way will generate a scalar first which cannot be crossed with a vector. So V cross B. So here V is in the positive y direction. So this is the direction of V, and B is in the positive z direction. So if we use the right hand thumb rule, then in such a case, let us say I have brought a right hand over here. So we are basically pointing the fingers initially towards the direction of V, which is the positive y direction, and then we are curling the fingers towards Z, which is the positive z direction. So if we do V cross B, then essentially we are going to get the value of EMF to be pointing in the positive x direction, meaning the battery that would be generated would be like so. So the electric field that is generated will basically be pointing in the positive x direction as per the right hand rule as shown. Alright, and hence here we can write the EMF to be VB sine 90. This is constant. Alright, so like for the net EMF we need to integrate this value of EMF. So this is integration of this, and now dl cos 0, because dl is nothing but a small distance along the x-axis. So this is simply dl, and we would actually need to integrate this from, let us say, 0 to the edge length of the cube, let's say a. So the EMF is going to be VB sin 90 cos 0, both are 1, V and B are constants, so we take them outside the integral sign, and then this is 0 to a integration of dl. So we'll be left with VB L, where L is the edge length of the cube. So basically this is 0 to a, that means this is going to be VBA. Now we just have to plug in the values, and the values happen to be V is 6 meters per second. Alright, B happens to be 0.1, and A happens to be 2 centimeters. So that is 2 into 10 raised to minus 2 meters. So this happens to be 12 into 10 raised to minus 3 in SI units. that is volts, because we are talking about EMF, so that is equal to 12 millivolts. So the option that has to be marked is option A.